Hello and welcome to my first video presentation on our subject Structural Theory 1. So we have learned that the coverage of this subject is more on determinate structures, and then later on it will be expanded to uh, Structural Theory 2, which discusses more on procedures and concepts relating to indeterminate structures. So for the meantime, let us tackle what are the importance of structural analysis for design resiliency as well as design serviceability, and then we will proceed to the references relating to structural codes and what are the existing codes in our locality in the Philippines, what are the references, and then we will learn the structural elements, what are the categories of a structure, the types of structure, as well as the loadings. We will learn how to compute loadings, where to get those values for our structural analysis later on. Okay, so let me relate to structural analysis for design resiliency. So, resilient design is the intentional design of buildings, landscapes, communities, and regions in order to respond to natural and man-made disasters and disturbances, as well as long-term changes resulting from climate change, including sea level rise, increased frequency of heat waves, and regional drought. So, as we all know that there are a lot of phenomena like earthquake, tsunami, storm surges, tornadoes, or in our locality we have landslide, liquefaction, and any other phenomena relating to natural disturbances. So, if we could only incorporate all of the criteria set by the code on these man-made disasters or disturbances or natural disturbances, then we will be having a resilient design, meaning your structure is adaptable to these disturbances and disasters. So this came from Resilient Design Institute. As for the design resiliency, your structure, a series of structures should be adaptable to storm, earthquake, tsunami, or even landslide, as well as tornadoes. So as for relating analysis for design serviceability, in our field of study, serviceability refers to the conditions under which a building is still considered useful. So the key term here is useful. Should these limit states be exceeded, a structure that may still be structurally sound would nevertheless be considered unfit. It refers to conditions other than the building strength that render the building unusable. Serviceability limit state design of structures include factors such as durability, overall stability, fire resistance, deflection, cracking, and excessive vibration. For example, a skyscraper could sway severely and cause the occupants to be sick, much like seasickness, yet be perfectly sound structurally. This building is no danger of collapsing, yet since it is obviously no longer fit for human occupation, it is considered to have exceeded its serviceability limit state. So, ang ibig sabihin lang niyan, when we have a structure serving as for a certain purpose, like this example, skyscraper, although the skyscraper is structurally sound, however, at a certain level, like for example, 100th floor, on that 100th floor the swaying is too much, of course, it will cause uncomfort to those users of this building. So another example would be, say for example, we have a drainage system. So on this drainage system, we have a good structural design or structural elements like uh, concrete canals or canal linings. Uh, Although we have a good one, but it may be that this drainage system is not sufficient enough to cater a certain volume of uh, water or some other uh, liquid to be drained, or it might be misplaced. There are drainage canal wherein there is no catchment of the liquid or the fluid to be drained. So in short, uh, the drainage system or the canal will not serve for its purpose, or would not optimize the section, for example. Okay, so that is for serviceability. So meaning the serviceability refers to the usefulness of a certain engineering structures, not more on the uh, soundness of its strength or what we call resistance to any loadings. Okay, so this definition came from the Wikipedia or the free encyclopedia on net. So what are the pertinent codes relating to structural analysis? Of course, in your subject, there are loadings, right? External loadings. So where does this loadings came from? So actually, these loadings came from references like American Concrete Institute or ACI, if we wanted to have a reference on concrete. So we refer to ACI 318-19. So if we wanted to have a reference for structural steel buildings, we would like to refer to AISC or the American Institute of Steel Construction. So if we wanted to have something that is related to transportation, we would like to refer to the codes set by AASHTO or the American Association of State Highway and Transportation Officials. So if we wanted to have more criteria on the loadings, design loadings, ASCE established those ones through their 7-16 codes or the American Society of Civil Engineers. So locally, we have the compilation of all of those reference could be found and improved under the National Structural Code of the Philippines that was authored by the Association of Structural Engineers here in the Philippines. Okay, so what are the NSCP requirements for design and serviceability? So this was contained in chapter 1 of the NSCP, the general requirements. So section 104 does have design requirements in terms of strength requirement, serviceability requirements, analysis, foundation investigation, and design review. So these are the things that we should consider in the design requirements. So all of the criteria like design review, it is when we design a certain structure, it is not a one-time design. So when we design a structure, it should be that your design should be subjected to a peer review, maybe twice, or it will have a design review stage. So a designated peer reviewer should come up with a checklist which will be discussed on the later slides. Okay, so section 105, of course, posting and instrumentation, posting of live loads, earthquake recording, instrumentation. So posting of live loads, where did you get your live loads? What code? So is it appropriate for that building or for that structure? Of course, we would like also to consider earthquake recording instrumentation. So what are your basis in the earthquake loading? Do you have recorded a previous earthquake occurrence, recording the parameters? So do you have an appropriate instrumentation in doing that? Okay. So section 106, we have also specifications, drawings, and calculations. So under this, we have general, specification, design, and drawings. So all of your specifications should be summarized into the sheet as well as the design drawings. So design drawing should have consistency in it, whether in the details as well as the layout and among others. So section 105, structural inspection tests and structural observations. So basically, the implementation is not stopped during the design phase. Of course, that is only the design phase. So the most important here is the implementation, or more important, or perhaps it is equally important to that of the design phase of implementing a project. Of course, what is in the design, for example, we have set a certain strength for concrete, meeting the strength requirement like 22.4 requirement for FC prime or megapascal, or a certain strength or grade 60 requirement for the steel bar. Of course, you wanted to assure that whatever in the design, it should be properly implemented. And how to do that? Of course, that is reach or achieve through quality control that you should implement also. So you have a mechanism on structural inspection, a mechanism on tests, and structural observation. So all of the procedures should be strictly followed, and all of the specifications should be strictly installed or strictly monitored. Okay, so we have general definitions, structural inspector, inspection program, types of work for inspection, approved fabricators, prefabricated construction, non-destructive testing, structural observation. So there are times that we need to have a prefabricated construction. Of course, you wanted to implement the prefabricated construction program wherein you assure the pre-stress design protocols. And if you wanted to have a evaluation, we would like to prefer non-destructive one, and then for the structural observation as well. Okay, so in implementing of government projects, there are a lot of checklists to follow in the implementation. Okay, so there are checklists for pouring of concrete, installation of rebars, and even design workability. Okay, or the workmanship, pertaining to the workmanship during and after construction. So that can be found in RPMS checklist that strictly to be followed. Okay, so let us have NSCP requirements for design review. So what are the items to be reviewed? Okay, so this is found under the Structural Code of the Philippines General Requirements. So the PR may include as appropriate or applicable any or all of the following. So under the item design basis criteria, we should look into the minimum loadings as set out in the code. Do you have met those codes or the requirements of the codes? And then next, we have prevailing site conditions and assumption in the design analysis. Does your criteria jibe with the prevailing site conditions? Okay, perhaps you have assumed a certain criteria like a stiff soil, but in actual, you should consider the soil unstiff, or the soil is weak, or you should consider soil testing first. Of course, that is a strict requirement to that. Okay. Next, we have material used in the design and specifications. And then we have reference to any assumed loadings, construction methods, analysis, and design. Okay. So what are your bases? Next, we have description of the operational language and or algorithms, capability and source of the software used, including proof of good comparison with results of known and accepted method of analysis. So, of course, there are a lot of procedures that will be introduced into the subject as well as the theory 2 subject. So, in your design basis or criteria, you should present that one. And if you intend to have a software in your design, of course, you should have to compare it with other methods accepted in structural analysis. As I have said, this is not a one-time design. It should be also reviewed. Okay, where did you derive your analysis as well as your design? And then for seismic design parameters and base shear, or so this is something related to earthquake or seismic design that is clearly defined also in ACI as well as the National Structural Code of the Philippines. So there are a lot of available maps locating your design relating to how far the site from the existing fault line. You should consider the factor. What is the magnitude? What are the magnitudes to be considered in your design? And then your factors related to base shear. Okay, so all of those are clearly defined in the Structural Code of the Philippines, and we wanted to assure that those are included in your design basis as well as the criteria. Okay, so number of mass participation for dynamic analysis is also considered, and then also the wind loadings, design parameters, and comfort criteria. So that is something related to resiliency as well as serviceability. Okay, so another item is design methods, standards, and specifications. So the specifics is conformance to the governing codes used in the analysis and design. And then we have also analysis models. What are your input and output data? So this includes geometry, material constants, properties, loadings, assignments, and parameters used in software used. Okay. So another is foundation loads, appropriate values of dead, live, wind, and seismic loads used. Column loads have been appropriately computed and compared to results of analysis model. Effects of wind and notional loads on the building or structure have been checked. Okay. And then we have piles. So there are a lot of specifics here relating to piles. By the way, piles are used to enhance our foundation, especially in the bridges lying under a certain river or a sea or ocean, perhaps. So it is advisable to install piles there. So a lot of criteria that should be considered, like the friction, the skin friction, the penetration depth, the uplift forces. So anchorage, so that is very important, the anchorage. And then the loads and bending moment. We should also have to check for the buckling, and then the pile reaction as well. So for isolated pads, combined footing, or even tight footing, so let us have to check punching shear and bending moments. So for raft, what is a raft? Raft actually is what we call the mat foundation. So when we have a multi-story building, usually it will have a raft foundation because a higher level or more floors or more weight to be transmitted to the foundation requires more requirement of the area or the area of a certain pad or foundation pad. So when that happens, usually in between columns, the foundation usually will eventually combine, and then all of the columns will have a single foundation. Okay, we'll have a single foundation. That is a mat foundation. So there are a lot of checks to be done here, like did you check allowable bearing capacity that has been assumed in the design? Of course, we would like to get the centroid of that one, or the neutral axis. Then we have appropriate modulus of subgrade reaction of the soil has been assumed in the design. So your geotechnical engineer should come up with those criteria, and then you should also consider that in your design. So appropriate model used for structural analysis of the raft. The raft has been designed to resist punching shear from columns. The building or structure has been designed to cater for probable differential and total settlement. Okay, for lateral load resisting framing system as assumed in the design basis criteria, we have specifics: the presence in the structural framing of any plan or vertical irregularities mentioned in NSCP or governing codes. So limitations of lateral load resisting framing system by NSCP or by the owner client preferred code and standards, or from any prevailing local ordinance and regulations in the vicinity of the proposed structure. So all of those should be met, as well as the details of seismic resistant concrete structure, checking of that. And then we have also items for slender columns. So do we have a sufficient cross-sectional area that is compliant to the code. Bending moment about minor axis has been designed for. Additional bending moment due to slenderness has been designed for. Biaxial bending moment has been designed for. Requirement for ductility such as strong column weak beam is provided or complies with the code. So, requirement for strong column weak beam. As we can see, dapat yung column is stronger than that of the beam. Why? Because once there is a lateral movement, there will be no room or less time for evacuation. So what is important here is the collapse mechanism. The first thing to collapse is, or the first thing to fail is the column before the beam. So it is important that the column capacity is more, or there should be a stronger column capacity than the capacity of the beam. So usually if a certain column carries a series of beam, like for example, it carries 4 beams or on both axes. What you do is to combine the strength of the two and then transmit it to the column and design the column to resist both beams that are attached to it, that are attached to it, so that you will be having a strong columns and weak beams. That is the concept in the earthquake design: strong column and weak beams. Okay, so columns supporting transfer beams. So it must be designed for bending moment due to frame action, including effects of spatial load combination per code. Okay, so we have also columns supporting long span beams. So we should have to control the deformation if we have a long spans. Okay. Columns supporting cantilever beams, designed for bending moment due to frame action. So cantilever beams refer to a overhang beams. Okay. So columns in a 2-column frame system. So it must be designed for horizontal load and moment acting on columns due to arc or pitch roof. Designed for bending moment and shear at the column base, including connections. Designed for bending moment due to frame actions. So we have also items for cantilever beams, long span beams, transfer beams, flat slab, or plates. So may we note all of those specific that should be checked or to be carried out by the peer reviewer. So we also have engineering drawings. It should be consistent, as I have said. The drawing should be consistent, architectural or structural, as well as the embedded items in some other discipline like mechanical, plumbing system, water system, electrical, and among others. So complete section in these details, it should be clear. Okay, so basically the plan should contain all what you need, or all the details you need, even if there is no consultant with you. Okay, so structural calculations should also be checked. What are the combinations, the load combinations that are used, what type of framing system you have used, structural geometric model. So does it comply the minimum dimensions of a certain framing system, consistency of design loading with the criteria and the equipment data, finishes plus the possible construction method requirements, effect of foreseen temporary works and activities during construction, and among others. Of course, for example, during implementation, it is expected that when you have construction of a multi-story building, it is expected that during construction there will be vibration going on, like one bagger mixer in a certain floor. You should also consider those ones. And if you intended to have stockpile on that certain construction, you should also consider this, or you should expect this uh, temporary works or activities during construction. Okay, so of course, an item for structural deformation and displacement check, we wanted to control that one. Stability factors or safety check. We also have earth retaining structures as well as the frame. Okay, so SMRF here under the framing refers to special moment resisting frame. SMRF usually are framing system that are earthquake resistant. Okay, we should also have to check for plan and vertical irregularities. So it is not good if, or we should be cautious in our configuration on our framing system, because sometimes we have not considered irregularities. What are irregularities? For example, we have as a building that is a C-shape structure or configuration, or a configuration that is irregular in floor level. Okay, what is that irregularities? For example, there are reduction in span as we go higher, so those are irregularities. Or if we have uh, different dimension, so those are irregularities going on in a structural framing configuration. So now let us move on to structural elements. Structural elements actually has to form and purpose. The whole structure consists of various types of structural elements in which a structural engineer should recognize. So these are categorized actually in, first we have line elements and the shell elements. Okay, so line elements consist of rods, which caters axial loads. So axial loads, as we all know, that is either tension or compression. Then we also have beam, axial and bending loads. So columns, it may be axial and bending loads also. So a certain column that is carrying both one is what we call column beam. Okay, so columns that act as a beam, because columns usually carries axial, but if there is a an earthquake or a wind that will cause lateral movement, that is where the column acts as a column beam, or meaning it carries axial and bending loads. So as part of this, we have ties, I-bars, guy wires, suspension cables, or wire ropes, so which carries tension loads or even shear loads. So for shell element, Uh, we have membrane in plane loads only, shell in plane and bending moments. We have concrete slab and deck, as well as shear panel which carries shear loads only. As for the rods, these are elements, frame or truss cross bracing, could be in tension or compression whenever there is a sideways movement. As we can see in the photo, we have the cross bracing. So the cross bracing has no implication if this structure caters only the gravity loads. However, if there will be a side swaying or lateral loads, those cross bracing will be subjected either in compression and in tension. So again, a side sway would cause this cross bracing to function. Okay. So next we have rods. So rods used in turnbuckles as a tensile member. So usually these rods will stiffen your roof framing system, and it is being stretched out by turnbuckles. So as we can see, the rods, in between rods, we have a turnbuckle. So a turnbuckle is a connector between these two rods, wherein there is a thread on it. If you're going to tighten that, it will have an initial tensile force. And this initial tensile force would tend to brace up your framing system. So another example of rod is sag rod, or the purlin sag rod. So this can be found in a framing system wherein the purlins are connected by the sag rod in order to control the sliding down of this sag rod, okay, as well as the compressing of this sag rod. It is connected by the sag rods, okay, aside from the cleats that are attached on the truss itself, okay. At the same time, it will control the sideways movement of the purlin that is carrying the roof material, okay. So rods are also used in suspension of a vehicle. So you can find that being a compression rods. So these are line elements also that can be used to form a truss, okay. So a series of rods would tend to form a truss. We have the top and bottom cord and web members, of course, to connect the roof materials. Okay, so for the beams, so this again, this is a single member beam, usually connected to another member. So when it is isolated, it is a line element. So these are structural elements that are horizontally placed in framing system to carry vertical forces and during gravity loads or lateral forces during earthquake or wind loading. So as we discovered or acquired the knowledge on mechanics of deformable bodies, beams are usually subjected in shear and bending when we have a gravity loads as well as lateral loads. We have actually learned how to establish the shear and bending moment diagram. So actually those are procedures that came up with your analysis of beams, okay, for the design later on. So as for the type of beam, this is according to the support and configuration or continuity. So we have simply supported beam. It is supported by a pin connection and a roller support. We have cantilevered beam. It is restrained at the one of the ends, or it is a fixed support at one of the ends, or this is what we call the overhang beam or cantilevered beam. So for the fixed supported beam, both supports have a restrained support or fixed support, and then we have a continuous beam supported by a series of rollers. Okay, so most often beams carry both shear and moment caused by gravity loads transmitted to the member. So we have a typical beam cross section. So it could be that your beam will be in terms of a structural steel shape. Usually a wide flange is used. So flange refers to the outer member. Flange usually is the outer member that carries more of the bending. So that is the function of the flange. So as we can see here in the photo, that is the flange. That is what we call the flanges of a wide flange. And then for the web, the function of the web is to resist the shear forces of the beam. So another typical beam cross section would be a T-beam. When we have a monolithic type of construction wherein the cast in place or the pouring of concrete for beam and slab will be conducted once, what will happen is that the slab would become an integral part of the beam. So meaning the slab now is a part of the beam, and the cross section will become a T-beam. Okay, will become a T-beam. So we will have a notation here. If the loading effect is more on bending, we would like to increase the width or thickness of the flange. And if the loading effect is more on shear, we would like to increase the depth or thickness of the web. So of course, we have solid rectangular beam as a typical one, or we have a hollow rectangular beams, or this is what we call the tubular beams. Okay, so beams also could be utilized as a girder. What is a girder? So a girder is a larger beam that carries a series of beam just to break the length. So usually just to break the length that is used in the flyover or in the building system, having a long span beams. Okay, so just to break the length, because as we have a longer span, there will be a deeper cross section. Okay, so beams used as stringers. So stringers in a bridge would carry the floor system of the bridge itself and then transmitted to the floor beam, and then the floor beam is attached now to the joint of the trusses. That is why when we analyze a bridge truss, usually the load is at the joint, is set at the joint, because by principle of superposition, those transmission finally will be transmitted to the bridge itself. Okay, that is why the bridge carries, or the bridge truss carries the bridge loading. Okay, so whenever there is no truss in it, stringers is placed on the girder, and the girder will support it, and the stringers will be supported by the girder. Okay, so we also have laminated beams. So laminated beams usually a engineered wood constituted by layers of dimensional lumber bonded together with durable moisture-resistant structural adhesives. So in North America, the material providing the laminations is termed as laminating stock or lam stock. By the way, glued laminated timber is abbreviated as glulam. And usually these timbers are connected by plate and bolt. Okay. So columns. So columns, as we all know, are vertical members. So this carries the structure actually. Used to resist axial compression for gravity loads and combination of both axial and bending for lateral loadings when earthquake or wind loading is applied. It could be in the form of reinforced concrete or steel section. Okay, so it is important that we should also always have a steel, whether your column in the form of reinforced or pure steel. Why? Because concrete is weak in terms of carrying bending loadings. However, it is stronger. It has a strong properties to resist axial loading, whether that is compression. Okay, compression or compression actually, but weak in tension or bending. Okay, that is why your concrete is supplemented by steel bars to have a resistance to bending. Okay, that's it. So as for the ties as a line element, it is usually used in beam and column in order to wrap the main bars. Why do we need to wrap the main bars? To have a shear resistance. Okay? Usually in beams, the wrapping ties is stirrups, and columns it is called as ties, simply ties. And then for the I-bar, we have the I-bar. Usually this is a straight rod with a hole on the edges, of course, to connect basically the members, okay, by a pin connection. So I-bars are used in structures such as bridges, in settings in which only tension and never compression is applied. So as we can see here in the photo, it is being used as a truss member. Okay, a truss member. So for another line element, we have guy wires, a guy wire, guy line, or guy rope, also known as simple. A guy is a tension cable designed to add stability to a freestanding structure. So usually in towers, you can see that in towers locally, like towers of the electric corporation, towers of the cell site or a cell site tower. So this is a freestanding because there is no brace in it. So the guy wire would act as the brace, and it is usually anchored on a foundation or what we call a dead man or a concrete anchorage for that cable. Okay, so next, suspension cables. So this could be found in some old structures like Magapit in Lalo, Cagayan, that is made of a series of suspension cable. So what is advantageous to a suspension cable? It could support a larger span of a bridge without having a more deeper member. As I have said a while ago, while we are having a longer span, it requires a deeper member. Why? To control the deformation. However, the feature of suspension of cable of suspending a certain structure, we can avoid using a deeper member. Just use a cable. So a suspension cable is used to support a large bridge span created from thousands of small steel cables wound into one large suspension cable. The roadway of a bridge hangs securely from the cable. So this came from Lori Kilcherman. So suspension cables as well is used in hanging bridge as well as cable cars. As we can see, we can found that a lot of it in hanging bridges locally available, like bridges in Buscalan, Tinglayan, and then also we have cable cars and tram lines used to transport uh, what are needed in agricultural production or agricultural products. So this could be found in Iloilo. One is found in Iloilo. Okay. So the feature of the cable is that it is moving, or it is not. It is swaying sideways or uh, bouncing, but not too much. Okay. We would like to control that movement. Okay. So how suspension bridge works? Of course, the hanging feature of a suspension bridge. So there will be a main cable, wherein this main cable carries the sub cables that are attached to the flooring of the bridge. As simple as that. And then we have a pylons, of course, as an additional vertical support for the main cable. Okay, so let us now proceed to membrane. Membrane structures are spatial structures made out of tension membranes. The use of membranes can be divided into pneumatic structures, tensile member structures, and cable domes. So the feature of it is we could build a structural wonder or architectural wonder, as we can see in the picture. And of course, a certain light material such as member would only require a light material for its framing system. Okay, so one of which another shell element is a shell structure could be found in Araneta Coliseum in Quezon City. It is a dome type structure having its roof as shell element. So you know the span of Araneta Coliseum. It is a tremendous span, and it could be uh, shell element. The feature of shell element could be installed on a larger span of covering the roof of Colosseum, like in Araneta. Okay, so why is it we would like to incorporate? Because first of all, the dome shape is a reverse curvature, wherein instead of having a bending effect, it will have a compressive effect because it is a reverse shape. Okay, at the same time, this shell element has a series of reinforcement. It is a slab actually, okay, rather than use a lot of trusses in order to come up with your uh, roof covering. Okay, so as part of the shell structure is a concrete slab. As we all know, a concrete slab is a suspended slab connected to the beam. Okay, and then it is reinforced by RSB, or reinforcing tilbar space as a certain design spacing. Okay, this is purely dependent on the loading as well as the rod diameter. Okay, so shell panels is used to serve as a side covering. Of course, we need to cover our structure for aesthetic purposes as well as the protection. Okay, we can find one in the Kalinga State University in our gate, wherein you can find ACP there, or aluminum composite panels, to cover a gate or the column of the gate for aesthetic purposes. And of course, shell elements would require a framing system or studs. Okay, so we have here the diagram, and that's as simple as that. Structural systems. As I have said, if there are combined structural elements, it will become a structure or structural systems. We have trusses, frames, cables and arcs, and surface structures. So trusses are series of structural members usually formed in triangular configuration. Trusses are built so as to support large span, quarry roof loadings, and provide horizontal stability like bridges and towers. So trusses is configured to form a three-force member. Why three-force member? It is so advantageous. Why? Because when we form a triangle, usually there are members, or two of the members are in diagonal. And if we have a diagonal, there are horizontal and vertical components. And if this series of members are combined, there will be a stiff effect because of the horizontal and vertical components caused by the triangle. Okay, unlike frame, in a frame or structural frame that has only vertical and horizontal members, there is no triangle in it, so therefore the column is only concentrated to carry the vertical, and the horizontal one or the beam just a bracing for the column. At the same time, it carries the horizontal forces. Okay, so the effect is shear and bending. Unlike in the trusses, it would only become either tension or compression, or actually loaded. So take note of that. So trusses loading is only axial, but less on bending. Okay, so cables and arcs, series of cables and members usually advantageous to along span bridges. As we have been telling a while ago, the arc feature is a reverse curve to resist a bending, so that the effect to the structure is in compression. So the reverse curvature feature of arcs tends the structural member to reach strength under compression, which minimizes bending stresses. So on the photo, you can see there, San Juanico Bridge in latest supports greater span. Okay, so for the frame, these are actually just the combination of the trusses. And the combination of trusses will become a framing system. So framing system are usually analyzed as indeterminate structures, because usually because of the there are a lot of members, so eventually there will be a lot of unknowns also. So if there is a lot of unknown, there are a lot of unknown, we cannot use the three equilibrium equations alone, but to supplement it by a series of procedures that will be introduced to you later on. Okay, so we cannot limit ourselves to the three equilibrium equations, but for the meantime, in theory 1, we are dealing with determinate structure. So surface structure, we have folded plates of small thickness features light material which permits economical framing system. Folded plates or shells innovates architectural wonders. So that's it for the first presentation. I hope you learned a lot from that, and I hope you will supplement your learnings with other references available in the internet. So please stand by for the next video tutorial. So thank you for listening, and see you around.